All right, these are the answers to page 1.5 or 185, expanding and condensing logarithms. So number 10, we have express a logarithm in terms of ln of 3 and ln of 7, and it's ln of 49 over 81. Well, 49 is 7 squared, and 81 is 3 to the 4th. And so when we take the ln of that, we can first subtract them. So we are here, 3 to the 4th. That's a little 4. And then we can bring the powers out. So 2 times the ln of 7 minus 4 times the ln of 3. Then number 12. We have the ln of 147. This one might seem tricky at first, but 147 is 3 times 49. And so 49 is 7 squared. So it's the ln of 3 plus the ln of 7 squared. So we have the ln of 3 plus 2 ln of 7. Problem 28 says evaluate the logarithm. And so we have 36 ln of e to the half minus 4 ln of e to the 5th. So it's important to realize that when the log and the base are the same, they cancel. So this cancels, and that cancels. And so when you're canceling, you're left with 5, and you technically have 36 times a half minus 4 times 5. So 36 times a half is 18. And so 18 minus 20 is negative 2. Then the next one, we're going even, so number 30 is we are expanding. Third root of x plus 2. It's important to realize the x plus 2 is never going to break apart. So first break it apart into subtraction. And it's a cube root. And remember that the cube root can be rewritten as a third. So this is the same thing as x plus 2 to the 3rd power. So your final answer when you bring the power out is 7 ln x minus 1/3 ln of x plus 2. 32 is the ln of 4 df to the 5th over the 8th root of 1 minus 3d. This is very similar to the previous one. So first break it apart. The ln of 4 df to the 5th minus the ln of the 8th root of 1 minus 3d. All of these individual multiplication can get broken apart. So the ln of 4 plus the ln of d plus the ln of f to the 5th. This one, and then we'll go ahead and keep simplifying this. The ln of 4 plus the ln of d plus 5 ln of f minus. Let's kind of go back up here. We've got to rewrite that as a power. So we have the ln of 1 minus 3d to the 8th. And so we can bring the 8th out. And there's our answer. Number 34 we have a giant log, no fraction, so the log base 7 of h squared, j to the 11th, and k to the negative 5th. If you wanted, you could move that negative 5th to the bottom of the fraction, but you don't actually have to, because all of these break apart into the log base 7 of h squared plus the log base 7 of j to the 11th plus the log base 7 of k to the negative 5th. And then bring all those powers out. So 2 log 7 of h plus 11 log 7 of j plus, when you bring the negative out, it'll be a minus 5 log 7k. And we've got 36. It's the log base 5 of a to the 6th, and b to the negative 3, and c to the 4th. And so, again, we break it all apart. So, log base 5, a to the 6th, plus log base 5, b to the negative 3, plus log base 5, c to the 4th, and then bring all the powers out. So 6 log base 5a plus negative 3, so that would just be minus 3. Is log base 2 of 3x plus 2 over the square root of 7, 1 minus 5x. So break it apart. Log base 2, make sure you put parentheses here, minus and this is to the 1/7 power, and then you just bring that power out. So log base 2 of 3x plus 2 minus 1/7 log base 2 of 1/5 minus x. Now it's time for 40, which we are condensing now. So 5 log base 7 of 2x minus 1/3 log base 7 of 5x plus 1. Since it's a minus, it's going to be a fraction. So first you want to bring your powers back up. So the 5 is going to go there, and the 1/3 is going to go there. So now we can write it as a big fraction. Log base 7, big fraction, 2x all to the 5th, and then 5x plus 1 to the 1/3. You could also write that as the square root or the cube root of 5x plus 1. It's the same thing. I don't remember what the answer posted online is. 4 ln of x plus 3 minus 1/5 ln of 4x plus 7. So, again, bring the power back up. Bring the power back up. This is a minus, so it's going to be a fraction. Ln of x plus 3 to the 4th. And then we have 4x plus 7 to the 1/5. 44. We've got ln 13 plus 7 ln a minus 11 ln b plus ln c. So even though these are written in a strange order, it's important to realize that some of these are going on the top and some of these are going on the bottom. So first the powers are going to come back in. So it's a to the 7th and b to the 11th. This is a negative, so it's going in the bottom of the fraction. So b to the 11th. But the rest of them, 13 a to the 7th, and then c are all on the top. (46) log 2 of x minus log 2 of y minus 3 log 2 of z. So similar to the previous one, bring the power back in. This power is going right here. We've got the log base 2 and a big fraction. Anything that's negative is going in the bottom, so the y and the z to the 3rd is in the bottom, and the x is in the top. And the last one in this section, number 48, log base 3 of 4 minus 1/2 log base 3 of 6x minus 5. So again, we have a fraction. We have to bring the half power back in. So log base 3, fraction, 4 on the top, because that's positive. And then a half is always a square root. Now we move on to number 69. Which says we expand, and so we have another expanding problem. This time we have a 5th root of x to the 3rd times x plus 3. So first, remember the 5th root can be written as a power. So I'm going to bring the 5th root out. 1/5 times the ln of x to the 3rd times x plus 3. Then you can break apart the multiplication, remembering that this is all still to the 1/5 power. And then you can bring the 3 out. Like so. You can leave it like that, or you can distribute the 1/5 to everything. They are equal. Now we're doing 70. 70 is another expanding problem. The log base 5 of x squared y to the 5th over the cubed root of x 4x minus y. So breaking it apart, and then you can break this one apart further. So log base 5 of x squared and log base 5 of y to the 5th. And then this one we can go ahead and rewrite as a power. And then we bring all the powers out. So 2 log base 5 of x plus 5.
The following students to the attendance office:
log base 5 of y minus 1/3 log base 5 of x minus 4x minus y. Then we have 80.